Hello students, how are you all? I hope you all are well and safe at your home. Welcome in your science class. In our previous class, we were discussing the chapter number 11, force and pressure. In that class, we discussed the various topics related to the force. Now, today is the turn to discuss about the pressure. Now, the question arises, what do you mean by the term pressure? The effect of force is measured by a physical quantity known as pressure. I'm again repeating. The effect of force is measured by a physical quantity known as pressure. Or you can say that pressure can be defined as the force applied per unit area. The smaller the area, the greater is the pressure, and hence greater is the impact of pressure. The formula for the pressure, that how it is related with the force and area. Pressure P is equals to force F divided by area A. So pressure is equals to force upon area. Let's understand the SI unit of pressure. SI unit of force is Newton, area is meter square, so its unit is Newton per meter square. SI unit of pressure is Newton per meter square. In spite of Newton per meter square, we can write Pascal. Pascal, Pascal, Pascal or Pa. Unit Pascal, Pa, is named after the French scientist Blaise Pascal, who gave the concept of pressure. Pressure depends on two factors. One is force, another is area of surface. Pressure is directly proportional to force. Hence, the greater the force, the greater is the pressure, and vice versa. Area of surface. Pressure is inversely proportional to the area of surface. Means the greater the area, the lesser is the pressure. Means pressure increases as the surface area decreases. You have seen the shoes. If the base of the shoes is wider, then means area is greater and it acts less pressure on the ground. If you saw the shoes with the pointed heels, in that case the less area is in contact with the ground, so it acts more pressure on the surface of earth. Let's see the figure carefully. For a solid block resting on the floor, the pressure acting on the floor is highest when the block is resting on its smaller surface. Here the two figures are there. Same box is there. In one box it is biggest area is lying on the surface, and in the another one the smallest area is lying on the surface of earth. So what happened when the area is bigger, smallest is the pressure, and in another one when the smallest area is there, biggest pressure acts on the floor. Let's study the numerical. Or for when you are doing the numerical, make sure that you will use the notebook and the paper pencil. Calculate the pressure exerted by a brick when applies a force of 2.5 Newton. When it is placed on its widest base, it is placed upright on the soil. The length, breadth and height of the brick are 25 cm, 10 cm and 5 cm respectively. Observe the figure. In this case, 25 is the length, 5 is the breadth, 25 is the length, 10 is the breadth, and 5 is the height. All these are in the centimeters. Now let's take the A part. When the brick is placed on its widest base, means in that case 25 centimeter length and 10 centimeter breadth is in contact with the surface. So we have to calculate its area. Area of a rectangular space is length into breadth. But I make sure that one thing, we have to take the SI units of all the things. Here this length and breadth is in the centimeter. So what we have to do? We have to convert it into meters. So 1 meter is equals to 100 centimeter and 1 centimeter is equals to 1 by 100 meter. So we have to convert this 25 centimeter and 10 centimeter into meter. So 25 by 100 meter into 10 by 100 meter. So it means 0.025 meter square is the area of the contact with the soil, means length into breadth. Force is given to us, that is 2.5 Newton. So pressure is equals to force upon area, and force is 2.5 by area 0.025 meter square. So the answer will be, when you will solve it, that will be 100 Newton meter square or 100 Pascal. Let's see the B part. When the brick is placed upright, in that case the 10 centimeter breadth and 5 centimeter height area is in contact with the soil. So area in contact with the soil is equals to length into breadth, that is equals to 5 centimeter into 10 centimeter. As I have already told you, you have to convert centimeter into meters. So 5 by 100 meter into 10 by 100 meter, the answer for the area will be 0.05 meter square. Force already given, that is 2.5 Newton. Pressure is equals to force upon area, that is 2.5 by 0.05 Newton per meter square. So the answer will be 500 Newton per meter square or Pascal. So observe the answer. In the B case it is 500 Pascal and in the A case it is 100 Pascal. So in which case the more pressure acts? In the B case, when the less area is in contact with the surface of the soil or with the floor. So it means less the area, more the pressure. Now let's study the application of pressure. A sharp knife has a very small surface area on its cutting edges, so the high pressure can be exerted to cut the vegetable or the fruits. Nail needles and the pins have very sharp ends with very small surface area. When a force is applied to the heads of a nail, the pressure will drive its sharp end into the piece of wood easily. The studs on the football boot you have seen, means on the shoes. The studs on a football boot have a very small area of contact with the ground. The pressure under the studs is high enough for them to sink into the ground, which gives them some extra grip. Skies have a large area to reduce the pressure on the snow so that they do not sink into too far. A tractor moving on the soft ground has wide tires to reduce the pressure on the ground so that they will not sink into the ground. You have seen the camel with a very large foot area because it is to reduce the pressure on the ground so that they will not sink into the sandy soil. A wide shoulder pad of a heavy bag will reduce the pressure exerted on the shoulder of the person carrying the bag. You have seen the workers place a round piece of cloth on their heads when they carry heavy loads. This is done to increase the area of contact with the load so that the pressure of the load on their heads is reduced. There are wooden concrete sleepers below the railway tracks. It reduces the pressure exerted by the trains on the ground. Another one is piercing of object is done by using sharp needles. This occurs because the area of the tip of the needle is small. It makes it easy to pass through the objects. Similar applications you might have observed many more. Let's test ourselves. In which of the following case is the child exerting least pressure on the ground? A, B, C or D? Least pressure. Least pressure means more area. More area is in which case? B case. More the area, less is the pressure. Because the formula is pressure is equals to force upon area. Do liquids also exert pressure? What is pressure in liquids? We know that the liquids have weight. For example, water has weight. When it is filled in a container, it exerts pressure on the walls of the container due to its weight. If you see a leaking pipe, note that the water coming out of the pores. You must also have seen the bath showers and the fountains from which water comes out of the tiny holes. In all these cases, you can feel the pressure of the water. Means it shows that liquid in a container exerts pressure because of its weight. Pressure exerted by liquids. Liquids exert pressure on the walls of the container. Liquid exerts pressure on the bottom of a container. It depends upon the height of the liquid. We will study all these one by one also. Liquid exerts sideways pressure and liquid exerts equal pressure at the same height, and liquid exerts pressure which increases with depth. In the first two cases, see the figure, in the first two cases, the balloon is attached on an open pipe and the water is filled. In first case, the water quantity is less, but in another case, the water quantity is little bit high. So what happened? The more pressure is acted in the downward direction. In the third figure, the hole is on the side of the container or the bottle. It means that wherever it is, it exerts the pressure on the wall of the container. And in the fourth case, the holes are there in the pipe at the same height, and it shows that equal pressure exerts at the same height. See the figure and understand the concept. A liquid exerts pressure on the walls of the container. Liquid exerts pressure on the bottom of its container, which depends on the height of its column. Means up to which height the pipe or the container is filled. More the height, more is the pressure exerted in the downward direction. Liquid exerts equal pressure at the same height. Water pressure increases with depth. Means that the deeper into a liquid you go, the greater the weight of the liquid above and the higher is the pressure. Now, how to measure the liquid pressure? An instrument used to measure liquid pressure is called pressure gauge. The simplest form of pressure gauge is manometer, which means pressure difference. We will study the manometer in this class too. Now let's study the atmospheric pressure. Earth is surrounded by air. The pressure caused by air in the atmosphere is called the atmospheric pressure. I'm again repeating, the pressure caused by air in the atmosphere is called the atmospheric pressure. The atmospheric pressure changes with change in altitude. It decreases as we go up from the surface of the earth. For example, the air in the tires of vehicle and bicycle exerts pressure which enable them to run nicely. Atmospheric pressure as an indicator of changes in weather. Meteorologists used barometers to predict the short-term changes in the weather. Barometer is a device which is used to measure the atmospheric pressure. It means the atmospheric pressure is the pressure of air around us. It is due to the weight of air. Let's see the figure. Here we have an air column of having area 10 by 10 centimeter. The weight of an air column of height of the atmosphere and area 10 into 10 centimeter is as large as 1000 kilogram. Why do we get crushed under this pressure? The reason is that the pressure exerted by the fluids in our body is equal and opposite to the atmospheric pressure acting on our body, and thus it cancels the effect of the atmospheric pressure. I've already told you the atmospheric pressure is measured by a device named as barometer in millimeter of Hg, means mercury. Air exerts pressure in all directions. See the figure carefully. The steam inside the bottle has been condensed by the cold water and the bottle now has very little air inside it. It is crushed. The atmospheric pressure acting on the bottle from outside is therefore much larger than the pressure exerted by the air inside. This causes the bottle to get crushed. Let's see which factors affects the atmospheric pressure. Altitude. As we go to higher altitudes, the air becomes thinner and the atmospheric pressure decreases. Temperature. Air expands on heating and becomes less dense. Therefore, atmospheric pressure decreases with increase in temperature. Humidity. Water vapor is lighter than air. Therefore, humid air is lighter than dry air. Hence, air pressure decreases as humidity increases. Syringe. You have tried how to fill the syringe and you have observed the changes might. When the piston, see the figure very carefully first, when the piston of the syringe is pulled up, the atmospheric pressure inside the cylinder will decreases. Means low pressure is created. The atmospheric pressure outside pushes the liquid up into the syringe. That is how the syringe is getting filled. Straw. You have used the straw many times. When a person sucks through the straw, the pressure in the straw becomes low. The atmospheric pressure outside, which is higher, will force the water into the straw and consequently into the mouth too. Manometer. Manometer is a device for measuring pressure of the liquids. It consists of a bent tube containing one or more liquids of different densities, such as water or mercury. One end of the tube is open to the air and The other end is connected to a funnel which has a rubber membrane stretched across its mouth. On placing the funnel in the beaker or directly, we fill the solution in the U-tube pipe. The level of the liquid in two arms of the manometer changes. The difference in the levels of the liquid in the two arms is a measure of the pressure exerted by the liquid on the rubber membrane. The more the difference, the greater is the pressure exerted. It has a glass or plastic U-tube filled with liquid such as water, oil, mercury or alcohol. The difference between the two levels of the pipe is the pressure. Barometer. Barometer is an instrument used to measure atmospheric pressure. The air has a weight which presses against everything it touches as gravity pulls it to the earth. The barometer is designed as a glass tube with one end open and other end sealed. The tube is filled with mercury. This glass tube sits upside down in a container called the reservoir, which also contains mercury. The mercury level in the glass tube falls, creating a vacuum at the top. And the height of the column is 76 centimeter of mercury. The barometer works by balancing the weight of mercury in the glass tube against the atmospheric pressure. The level of mercury continues to change until the weight of mercury in the glass tube is exactly equal to the weight of air above the reservoir. Once the two have stopped moving and are balanced, the pressure is recorded by reading the value at the mercury height in the vertical column. If the weight of the mercury is less than the atmospheric pressure, the mercury in the glass tube rises, means high pressure. If the weight of the mercury is more than the atmospheric pressure, the mercury level falls, means the low pressure is there. So, I'm again revising what we have studied. We have studied about the pressure. We try to solve the numericals. Then we have studied the effects of pressure, application of pressure, pressure exerted by liquids, pressure exerted by the gases, atmospheric pressure, and then manometer and the barometer. And we have studied the application of the atmospheric pressure too. That's all in this chapter. I hope you have understood. We will meet again with a new chapter. Till then, bye bye. Thank you.